let's do some sine and cosine curves and graph them by hand. We have been talking about sine and cosine curves based on, here's the graph, write the equation, but now we've got the equation, we're going to draw the graph. Here's a reminder about the general form for these cosine and sine curves. The variables that we're using are A, B, C, and D. And then A is amplitude. The period is found by dividing 2 pi and B. Phase shift is the opposite of C over B. And then the midline is the equation of the line y equals your D value. So let's look at this first one here. It is a sine curve. Y equals 2 times the sine of x. Remember that sine starts and stops on the midline. So there's the general shape of what your curve is going to look like. So before we do too much, let's go ahead and figure out what these values are for your variables. Looking at the equation here, we see that A is 2, B is your 1 coefficient on x, so that's a 1. There is no C because in order to have a C value, you have to have parentheses, and there's a phase shift, but there's not one. And then we also don't have a D value because there's no number added or subtracted from our function here. So we're good to say 0 on that. All right, now, based on what we know about A, B, C, and D, the amplitude is your A value. And then the midline is y equals that D value, which is 0. And then the period we're going to find by dividing 2 pi by b, and b is just 1. So our period is 2 pi, which is just like the parent function of a sine curve. It looks no different as far as the period goes. All right, but the only thing that really is going to change is our amplitude is going to stretch up to 2 and scoot down to -2 on our high and low points. So here are your y-axis coordinates that we're going to need. And like I said, sine starts on the midline and stops on the midline. So before we do too much, let's go ahead and draw our midline. It's at y equals 0. So I'm going to draw that here. According to the definition of an amplitude, the highest and lowest points of your graph must be 2 units from the midline if the amplitude is 2. So our first point is on the midline. Our next point, which is hovering above pi over 2, is going to be 2 units from the midline. So that's why it's going to go here. The next point would be where we're crossing back over the midline, so that's going to be at pi. Our lowest point is aligning with 3 pi over 2, and instead of stretching down 1 unit, now it's got to stretch down 2 units, so we're going to be at -2. And then 2 pi, we're back at the midline. So that would be your graph for y equals 2 sine x. And this is just one complete cycle of that curve. That's all we're wanting to show. All right, let's move on to the next one. It's a cosine curve. Got quite a big amplitude change here from the parent function, and then we do have another vertical adjustment to make as well. So let's do our variables first. So let's look at A, B, C, and D. A is 5. B is, again, just 1. There is no C value because we're not doing a phase shift. And then the D value is -1. So what we can do is now identify the amplitude as 5. The midline is y equals a -1. And then our period is 2 pi over b again, which is just 1. So we're still at a 2 pi period. Again, that means all of our increments on the x-axis are still the same as they would be for a parent function. We've just got to make these adjustments to the amplitude and the midline. So let's do the midline first. It is at y equals -1. Let's get some y-axis tick marks on here. I'm running into my information here. All right, so the midline is -1. Went down too far, didn't I? All right, so there's your midline. Now, cosine has this shape to it right here. And these high points and low points, our amplitude from these points to the midline now has to be 5. So cosine normally starts 1 unit above the graph. That's where it normally starts. That's if it's an amplitude of 1. But and now the amplitude's got to be 5. So let's count 5 units from the midline. 1, 2, 3, 4, 5. So we're here at positive 4. The next point for a cosine curve is on the midline. So at pi over 2, we're back to the midline. Pi is where we scoop down to our lowest point in a cosine curve. So let's count 5 units down. 1, 2, 3, 4, 5. Then we're back at the midline at our next point at through pi over 2. And lastly, our 2 pi point should again have an amplitude of 5 above the midline. So we're back at positive 4. Right there is your cosine curve with an amplitude of 5 and a midline of negative 1, period 2 pi. One cycle is enough to draw. That's all we want to see. All right, so let's go now to talk about one. There's a negative number on our function. Again, let's start by identifying A, B, C, and D. So A is a negative 3. B is a 1. There is no C, and again, there's no D because we do not have a number added or subtracted from this function. All right, so the amplitude then, all right, we need to talk about that because the amplitude is a distance from the midline to the curve. Distance is not going to be a negative number because we're not giving it a direction. So your amplitude by definition is a distance from the midline to the highest or the lowest point. So we're going to just give that a positive 3 value because that's what amplitude is defined as. Your midline is going to be 0. And then the period again, since B is 1, is just 2 pi. So that's why I have set this up with the same exact x-axis labels that we've been using this whole time. All right, so let's sketch in the midline first. That's at 0. Here it is. All right, now, we haven't talked about it yet, but what does this negative do to this graph? All right, we're multiplying our function by a negative number. So that means we're going to have a reflection of our sine curve. And it's going to reflect over the midline, wherever it is. So that's why it's important to know where that midline is, because that's kind of what you base the rest of the graph off of. All right, so let's also talk about this before we get going. Sine normally starts in the midline and ends on the midline. That's not going to change in the case of a reflection. But what is going to change is that your mountain is becoming a valley, so to speak, and vice versa. So it's doing a little upside down reflection move there across your midline. So keep that in mind. And we've got to change our amplitude to 3. So let's just kind of do an in-between step on this one. I want to show you what that would look like. Let's just do a regular amplitude of 3 with no reflection and see what happens. Let's not do too much at one time because sometimes it is a little confusing. So if we were doing a regular sine curve with an amplitude of 3, it would look like so. It would reach positive 3, scoop back down to pi, down to negative 3, and then back up to 2 pi. All right, that's if it was a positive 3 sine x, but that's not what we want to graph. We want to graph the negative version of that. So that means that we're reflecting across the line, the midline. Points on the midline will stay on the midline. This point is 3 units above the midline. Now it's going to be 3 units below it. Same thing with this one. This one's 3 units below the midline. Now will be 3 units above. So reflecting across the midline makes your graph turn upside down or go in the opposite directions that it usually would go first. Alrighty. All right, let's do one more. This one's going to have an amplitude change, reflection, and a midline change. So let's identify our pieces first. We've got A, B, and this is our D value. So A is negative 2, B is 1, there is no C, and D
Good afternoon, Lake County High School. We want to wish a happy Veterans Day to our soldiers, both.
All right, we're back here. We had to pause for some announcements there. I went ahead and identified the amplitude as just a positive 2. Remember, we do not need a negative distance, so we're just leaving it as a positive. Midline at negative 3 and period of 2 pi. So we're going to sketch in the midline. And what I want to do again is an in-between step. I want to see what this is going to look like if we just did a regular amplitude of 2, and didn't do the reflection quite yet. So cosine's a little bit of a pain at times, but cosine normally starts 1 unit above the midline, but if the amplitude is 2, again, it stretches. And then, so here's what it would look like normally with just a regular 2 and not a negative 2 there for A. All right. But we are doing a reflection, so we need to reflect our points across the midline. So instead of 2 units up, we're 2 units below. Points on the midline are there. All these other points will reflect to the other side of the line. Oop, I missed that one a little bit there, didn't I? All right, so there's you a negative cosine curve with an amplitude of 2 and with a midline of -3.